Welcome to video number 19 for Ctrl Shift Enter Mastering Excel Array Formulas. Hey, we're in the workbook Array Formula DVD book start, and we're on the sheet topics. Hey, in last video we talked about unique count formulas. This video I want to switch gears and talk about the array function MMULT. MMULT means matrix multiplication. Hey, so I'm going to click on this link for sheet 19. I've jumped over to sheet 19. Now, everyone remembers matrix algebra from college, right? Solving system of equations. Hey, that's lots of fun. But most of us are not sitting around solving a system of equations or doing matrix algebra. But we do want to look at the MMULT function, which means multiplying matrices or arrays. Occasionally, when doing array formulas, it will help us do the seemingly impossible. So at least we want to keep in the back of our mind that there is this thing called MMULT that allows us to multiply arrays and get certain results. Now, we've got to talk a little bit about how to multiply these arrays. The first thing is when you have two arrays, you can't automatically multiply any two arrays. The number of columns in the first have to be equal in count to the number of rows in the second. And the reason why comes from how we actually multiply these arrays or matrices. The way you do it is you actually take the whole row of the first times the column of the second. Now again, a row is filled with columns. So you take these boop, 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 3 items in columns and multiply by boop, 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 3 different rows and add. And you do that for every single row and column. This is how it looks if you were doing it longhand, right? Oh, look at that. This row times that column. 3 columns times 3 rows. Then you do the next one. Oh, wow. This whole row times that column. And you keep repeating, right, until you get to the end. You've multiplied this row times all the columns. Then you come over here and do it for the second row times the first column. All right, so that would get pretty tedious. The amazing thing about the MMULT function is you just have to know how many cells to highlight it, type MMULT, put in the 2 arrays, and it does it all for you. But how do you know how many rows and columns to highlight before you enter your function? RC cola is the answer. So over here I wrote RC, meaning 2 rows, 3 columns. This one has 2 rows and 3 columns. This second array here has RC, 3 rows, 5 columns. So I always remember it's R from the first, C from the second. RC cola, right? So the red, 2 by 5. The resultant array is 2 by 5. 2 by 5, RC cola. So I'm simply going to highlight RC cola, 2 rows, 5 columns, equals tab. It's the only function that has 2 m's. Array 1, comma, array 2. And we've seen a bunch of array functions. You notice that I never type that closed parenthesis in because it'll put it in for you. But you do have to hold Ctrl Shift and Enter. You can see those curly brackets up there. As with all of the other array functions, you cannot delete a single part, right? You can't insert a column or do any other structural changes. That's a single unit. And Control / is the keyboard to highlight the current array. Man, that is absolutely amazing. All right, let's go look at some examples that perhaps are useful for you. We want to talk about an example we did back in video number 9 when we talked about SUMPRODUCT. This is a finance example. We have some returns for stock A and stock B. And we need to calculate, and these are based on past data, right? We need to, for our portfolio of stock A and B with weights 0.6 and 0.4, we need to estimate what our expected return is. Now, we have estimated that the probability of each economic state are these values right here. And what we did back in video 9 is we knew that the SUMPRODUCT could not handle arrays with different dimensions. So what do? We multiplied. And when we multiplied all these, we got the right values. That works here. Now, this works because we didn't have a return for stock A, and the cell was empty. But what if we had this situation down here where we had text? Now I'm actually going to copy this formula and paste it down here. Well, that's not going to work. We're doing a direct math operation, and you're not allowed to do math operations on words and numbers. But if there was a way, instead of doing the direct multiplication in a single array argument in SUMPRODUCT, if we could multiply this array times this array times this array, well, the SUMPRODUCT is programmed to ignore text. Well, here's the thing. We can use the MMULT. Now, remember, SUMPRODUCT needs same size arrays. Totally different than the MMULT function. But guess what? If we define this as array 1, 3 rows by 1 column, and we define this as array 2, 1 row and 2 columns, the resultant array would be RC 3 by 2. RC cola, right? So 3 by 2, that's the same size as this. Let's just try this. Equals MMULT. So array times array. We have to do this in the right order. First one times second one, 3, 2. The resultant one is going to be 3, 2. I'm going to highlight this right in the cell in F9. You've got to be kidding me. Now here's where knowing array syntax helps. So 0.3, comma, 0.2, semicolon. 0.24, comma, 0.16, semicolon. So sure enough, there are 3 rows. You can see 1, 2, 3. And there's 2 columns in each one. So perfect. That will work. I'm going to type SUMPRODUCT. Highlight this right here, comma, and there we go. That will work. Ignoring that text. Hey, by the way, this is another one of those tricks I learned from Aladdin at the Mr. Excel message board. Absolutely beautiful. Now here's another great example for where we can use the MMULT function. Now we saw this example back when we did SUMPRODUCT. We are trying to calculate a weighted grade. So Sue has these test scores, but the weights are orientated vertically. Now the solution to this is, the smart solution is to put the weights in as the same orientation as the tests. But if you had to have weights this way, tests this way, what are you going to do? Well, you're probably going to make a formula like this, right? Where you have all these relative cell references and all of these absolute cell references. That would be a hassle to create. Well, can we multiply these? Well, let's look. If this is the first array, this is 1 by 4, 4 columns, times 4 times 1. Remember, if you were multiplying arrays, just as it says down here, 1 by 4, 4 times 1, the column of the first has to equal rows of the seconds. 4 columns, 4 rows. Yes. And guess what the resultant size is? RC cola. 1 row, 1 column. You mean there can be a result that's a single cell? You bet. This is perfect for the MMULT. Now I'm going to take this array, which is a relative cell reference. That's the first one, times this array, which is absolute. Close parentheses and Ctrl Shift. Hey, wait a second. Why did I worry about cell references with an array function? I thought you said you Ctrl Shift Enter and it didn't matter, because we're going to enter this into a single cell and then copy it. So if you have an array function, after you enter it, you're going to copy it. Then you have to worry about cell references. Ctrl Shift Enter and double click and send it down. Absolutely beautiful. So MMULT came to the rescue here. Let's go down and see our next example. And this is going to be a doozy. All right, this example is from finance. And guess what? We've already seen this a few times. Stock A, stock B, probabilities of economic states, and weight. We know how to calculate the expected return. Now this one's pretty easy, and it's nice because we do it all in one cell. We don't have to do the intermediate steps, which if you were taking a finance class, you'd learn the intermediate steps. But I want to show you how to do standard deviation. I'm going to do this pretty quickly here because I want to ultimately build a single cell formula here. And one of the steps that we do when we're creating standard deviation for the portfolio of stocks is going to cause a major problem, and the MMULT function and matrix multiplication will come to our rescue. The first step in calculating the standard deviation is we want to calculate the return if our assumed state actually occurs. So we simply have to take these two returns times the weights, and that is a perfect job for SUMPRODUCT. Relative cell references, same dimension, times absolute cell references, same dimension. Ctrl Enter and copy it down. All right, so that's if the state occurs. But next we need to figure out what the deviation is. Oh, well, this is our expected return. So we need to, from each individual return, subtract our expected return. F4, Control Enter. Double click and send it down. Now, if we're going to calculate variation, the negatives and positives all need to be converted to positives. So we do that by squaring and copy it down. These individual squares need to be multiplied times the probability, and then copy it down. Finally, once we have this column here, we add it. That gives us what's called variance of the portfolio. To get standard deviation, we simply take square root of the variance. Absolutely many steps to calculate that, right? But how in the world would we do that in a single cell? Now, one of the cool things about creating your own array formulas is once you have this multiple step calculation and you've done it over and over, you then want to try and go backwards through it to create your own. So, well, square root, that would be easy. Variance, that's just the sum. But notice there's an array of values there, so we'd have to create that. Well, that's just that whole column times this whole column. Notice, bloop, bloop. This one would be, well, this whole column square. That's an easy enough calculation. This one is, oh, well, this whole column here, subtracting a single amount, which is perfectly all right. It's when we get to this one that we have a problem, because this entire column has to be inside the cell. So if we were going to start this formula, we'd have to already have F9, have those values in the single cell, right? Well, the next calculation is simply to subtract this. That's easy enough. And then the next subtraction, the next calculation is simply to square. And then the next calculation is simply to multiply times there. So all of those calculations we can do. It's just that little thing right there. How in the world are we going to do that? Well, let's look at this. SUMPRODUCT is multiplying that range times that range. That range times that range. Now notice the blue one here. The blue one. The blue one. It's as if we're taking this whole rectangular range and multiplying times that. Well, we could do that in our cell. We could take these entire values here and multiply it times those. But that is not, that's an intermediate step, F9. We need to take those values, this 0.006 and this minus 0.06, and add those together. If we were to add those two things together, we'd get that number right there. Now I'm going to Control Z and Control Shift Enter just for a second. Here's that intermediate step. When we multiply that whole range times that, we get this little rectangular table. And we could prove that to ourselves over here. F9, see, there it is. Number, go over a column number. Semicolon means goes down a row. 0.03, 0.02, there it is. Escape. So inside our formula, we know we can do that one. But it's getting this into this single column that's the problem. I called it MMULT to gather up values into a column. Well, what are we doing? We're adding, right? Now, I actually should have put this over here. And just shown you that we're just adding these, right? But let's think of this a different way. What if instead of adding like that, we multiplied that number times 1 plus that number times 1? Would that work? Well, sure it would. But here's where we have to make our creative jump and think about matrix multiplication. When we do matrix multiplication, this whole matrice or array here is 3 rows by 2 columns. If I want to end up with this single column here with 3 rows, which means it would be a 3 times 1, I'd have to multiply this times 1 and 1. But the 1 and 1 would have to be in a single column, meaning 2 rows. Notice when you multiply, one of the requirements is the columns from the first have to equal the rows of the second. So we could actually get this result if we multiplied this times 2 rows by 1 column filled with 1. So let's try this. I'm going to, inside the MMULT, I'm going to take this, which is that range right there, and multiply it. Now I'm going to use array syntax. Curly bracket 1, semicolon means go down a row, 1, end curly bracket. So here we're using our knowledge of matrix multiplication and array syntax, right? I'm going to highlight this and hit the F9 key. You got to be kidding. So here we have created this column inside a single cell. Control Z. Now the rest of it. Remember, that's delivering this whole column. This whole column needs to be individually subtracted from it that value. So I simply go minus. And I'm actually going to suspend this formula just for a second. I'm going to assume that I don't have that. I want to include everything. So notice that's given me the expected return. I suspended that with a space. Now I'm going to get rid of the space. And now I'm going to go Control V. Whoa. So there we have F9, that whole column right there. Control Z. Now what did I do? I squared it. Oh, no problem. I need to force that subtraction to happen first. So I have to put parentheses around this. And then simply square it. Notice we just did an array of values. And we subtracted a single value right here, F9. That's a single value. So when you do that, each individual value gets from it subtracted this 0.07. We've done just a similar thing here. We've taken this array of values, F9, and now we're going to do a single operation on it. So each one of these will get squared. And if I highlight this and hit the F9, oh, you got to be kidding me. Now, in this next column, we have to get this column, but it's an entire column times an entire column. So now I simply multiply. And check this out. So now when I highlight this and hit the F9, whoa, I've simulated that column. Now the rest of it's easy. I just sum and square, Control Z. So I sum the single number. The sum took that little parentheses there, so I'm going to have to add a parentheses there and then come to the end and close. And now when I highlight this and hit the F9, oh, you got to be kidding me. That is so beautiful. One more function to wrap around it, the square root. And now I have F9, my single cell formula for standard deviation. So this has many array calculations, so I need to Control Shift and Enter. You got to be kidding me. Now, one further, and by the way, I tried to create this formula myself many years ago, and I couldn't. This was the part I was having the trouble with, and I posted it at the Mr. Excel message board, and Dominique showed me this great trick. Not only that, but there's one step more we can do to this formula to make it robust. Now, robust means that the formula will accommodate any changes you make to the spreadsheet. I'm going to Control Shift Enter. One common structural change that people will make, especially to portfolios like this, is they might add an extra column and have a new stock and change the weights and then add all of these, whatever it might be here, right? So that's a structural change. But look what we did. We hard-coded these numbers in. So the golden rule in Excel is always, if something can change, put it in the cells and refer to it with a cell reference. Well, how am I going to put 1, 1, 1 and have it expand and contract as I add and take away stocks? I'm going to escape, Control Z, 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 Z. We'll come and do that again in just a moment. So we have to somehow simulate a column of ones, meaning 1, go down a row, 1, go down a row, 1, go down a row inside the formula, right? So here's how we could do it. We could notice, escape, notice that the information for how many stocks we have is coming from these cells, right? So if I move this over here and add one or insert a column, it's now 1, 2, 3 cells. Notice they're coming from columns. So the information about how many weights or stocks we have is coming from columns. So I'm going to try the column function. Remember, that's a semicolon, OK? But I'm going to try this column and highlight these two, and then close parentheses. All right, so now I'm going to highlight this and F9. Well, that's not going to work. I need 1. But it is giving me 2 positions. If I were to expand this, I would have 3 positions. Hey, any number raised to the 0 is what? 1. So exponent 0. And there I have, from that 2 positions, information there. F9, I have 2 1s. What's the remaining problem? That's a comma, and I need semicolons. So I'm simply going to transpose. You've got to be kidding me. And so now I have this transpose. F9, and there I have my 1, semicolon 1, Control Z, Control Shift Enter. And watch this. If I were to insert or move or whatever, you got to be kidding me. That is called robust. Now, there's a great word that Aladdin, I've seen him use at the Mr. Excel message board, robustify your formulas. Man, that is robustifying. All right, escape. I'm going to Control Z, 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 and Z. OK, MMULT and standard deviation for the portfolio. Pretty wild there. And also, that was certainly how we went backwards through our calculations and built our formula. That's something that takes practice in doing. And usually you have to do it a lot. But that skill really can help you create your own array formulas. Now, one last thing, if we're talking about MMULT, this is not a video about matrix multiplying. But there is the MINVERSE. And if you have a matrix and you need to find its inverse, you just use the MINVERSE. And it will take that matrix or array and give you the inverse. Now, this is just like MMULT. Control Shift and Enter. It delivers a bunch of values. And then you could do it here. All righty, that is a lot about the MMULT function. And actually, in our next video 20, we will talk about extracting unique lists and sorting formulas. And one of the really huge array formulas we do for extracting unique lists will use the MMULT. All right, we'll see you next video.